All right, for Chapter 12, Section 1, completing this set now, we have a solid cylinder that lies on or below the plane z equal 3 and on or above the disk in the xy plane with center, the origin, and radius 4. So if we try to again draw this in 3 dimensions, the plane z equal to 3. The plane z equal to 3 would be 1, 2, 3. And so we've got a plane in the, it's basically going to be exactly a square. So imagine that's up in the air, 3 units up. And then we have a disk in the xy plane. So there's a disk below this thing in the x with center at the origin. So in the xy plane, it would be right there, in radius 4. So here's x is 4, here's x is minus 4, here's y is 4, here's y is minus 4. And what you get is a circle in the xy plane. Now this is a solid cylinder, so this thing is going to fill up like a cylinder up and down the z-axis. So to capture this cylinder, to capture that circle, the circle is just defined by this: x squared plus y squared equals r squared. That's any circle at the origin of a plane, this plane being x and y plane, and we know the radius is 4, so this would have to equal 16, squaring 4. So that's this part, and now we use less than equal to because we want to confine that cylinder to be smaller than 16 radius squared. So we use less than equal to confine it inside that cylinder or on the surface of it. And then this is going to capture this, and it really is hard to see this. So this blue part is going to be sitting on the xy axis where z, in fact, let me use a different color here. That blue circle I drew represents just this point of z, when z is 0. Then this red sphere, the intersection of red and blue up here, this circle would represent when z is 3. So it's a circle, it's a cylinder stacked in the z direction from 0 to z equal 3. Really hard to draw, but I tried my best there. Okay, for problem 10, it says consider the point 3, 4, 5. And then it asks, what is the projection of this point on the xy plane? Notice that to be on the xy plane, z has to be 0. So all you have to do is replace the z coordinate with a 0. So it's just 3, 4, and then 0. To be on the yz plane, notice there's no x in that. X must be 0. So you replace this point with 0 in the x, and then the other two numbers are the same, 4 and 5. For the xz plane, notice there's no y written in that, so y must be 0. And so you replace the y coordinate with 0, and you have 3, 0, 5. And then the proper box shown would be this one right here. And if you look, those 3 points we just wrote are shown. So this is the point they gave. When we zeroed out the x, we got this point. When we zeroed out the y, we got this point. When we zeroed out the z, we got this point. So you can see those corner points are shown on that particular box, so it's the correct one. All these other ones have, like, these two numbers have been transposed. These two numbers, let's see, actually a couple of these numbers are mixed up. And then on this one, a couple of numbers are mixed up right there. So you can kind of eliminate them right away. Okay, now it says, find the length of the diagonal of the box. So the diagonal would be from this 0, 0 to this point right here. So it's this blue distance right here. Well, the distance in 3 dimensions of any point is, so let's say I have from the origin to point P. So let's call this P. the distance from the origin to P is going to be the square root of x minus the x value of P squared plus y minus the y value of P squared plus, I'm running out of room, z minus the z component of P squared, and all that's square rooted. Now what's nice is when you have the origin, x, y, and z all become 0. So for origin to this point that we have, it's going to be the square root of 0 minus the x point of that, 3 squared, plus 0 for the origin minus the y component, 4 squared, 4, plus 0 for the origin minus the z component, 5 squared. And that all quickly breaks down to just the square root of 9 plus 16 plus 25, which is the square root of 50, which you can pull out. You can write this as 25 times 2. But 25 can come out of the square root as a 5. Square root of 25 is 5, and that leaves the 2 inside. So you get 5 root 2. Okay, that's problem 10. Okay, problem 11 is pretty simple. X in 2 dimensions, R2 is 2 dimensions. When you say x equal to 2 dimensions, x equals 2, that is a vertical line that goes through 2. So we're going to have a line. Now in 3 dimensions, it gets more interesting. Oh, I can do better than that. In 3 dimensions, x, y, z. X equal to 2 becomes a plane. So it is going to be a plane that is through this point, and it's going to go up parallel to the z-axis like this. So it is an entire 2-dimensional space. So in 3 dimensions, R3, x equal to 2 is a plane. Okay, for 12, we've got to find the lengths of some triangular sides, so let's give it a shot. Okay, we had seen one really similar to this, so we just have to take the square root of each x value subtracted and squared, y value subtracted and squared, z value subtracted and squared. So from P to Q, Q is the endpoint, and we have 2 for its x value, minus 4 for the P x value squared. Then we take Q's y value, 1, minus P's y value, 3, square it, plus Q's z value, 1, minus P's z value, 2, and square it. This is going to give us the square root of negative 2 squared is 4, negative 2 squared is 4, negative 1 squared is 1, nice number, square root of 9, which is 3. Okay, let's try the next one. QR. R would be 2 minus Q. So the x value of R is 2. The x value of Q is 2. Square, that's going to be easy, 0. Plus the y value of R is 7. Minus the y value of Q, which is 1, squared, plus the z value of R, which is negative 2, minus the z value of Q, which is 1, squared. This is going to equal 0 squared plus 8 squared, which is 64, plus this is negative 3 squared, which is 9. And that's going to be the square root of 73. Ugly number. And that's because I made a mistake. Anyone see it? 7 minus 1 is 6. When I square that, it is 36, not 64. So we're going to get 36 minus 2 minus 1. Let me double check that one also. Minus 3 squared would be 9. This is the square root of 45. Not much better. That will break down into 9 times 5, and the square root of 9 is 3. So that's 3 square roots of 5. Okay, last one. We have P and RP, excuse me. P, the x value is 4, R, 2. The y value of P is 3. Minus the y value of R, which is 7. The z value of P is 2, minus the z value of R, which is minus 2. So we're going to get 4 minus 2 is 2, and 2 squared is 4. 3 minus 7 is minus 4, but I'm squaring it, so I get 16. And then 2 minus minus 2 is 4, squared is another 16. This one's nice, square root of 36, which is 6. Okay, is it a right triangle? To see that, we have to square the two small sides and see if they add up to the squared of the largest side. So the largest side is 6. We're just checking Pythagorean theorem in essence. So we're going to check, is 3 squared plus 3 root 5 squared equal to 6 squared. This should be 9 plus 9 times 5. So this squared distributes to both. Square the 3, it's 9. Square the root 5, it's 5. Does that equal 36? Not even close. This is going to be 9 plus 45. I don't have to even compute that. That's not going to equal 36. So this would not be a right triangle. Is it an isosceles triangle? Also, that's a no, because you don't have any two sides that are the same. So let's put in our numbers here and see if we have this right. Okay, so that's an extremely similar problem, although it is saying that I have this, is it a right triangle? It's saying I have that wrong. Now let's take a look at that and see where I might have made an error. Silly me, anyone see the mistake? I do now. 3 root 5 is the biggest side, not 6. So I picked the wrong largest side. I looked at it and said 3 root 5, oh, that's smaller than 6. No, it's not. It's actually bigger than 6. So we have to replace this side with 6 and this side with 3 root 5. So we're going to have 6 squared, which is 36. On this side, we have 3 root 5 squared. That's going to be 9 times 5. This is 45, and this is 45, which checks out. So even I will rush myself sometimes. That is a right triangle. Pythagorean theorem held. There we go, we got it. Okay, for problem 13, I've drawn the picture already, but let's look at it. So we have a point 2, -4, and 6. So in the x-axis, you go 2 units, and again, you have to do a right-handed coordinate system. So positive x goes towards this letter, positive y goes towards that letter, positive z goes towards that letter. So 2 in the x would go 2 down to the right. Then -4 in the y would go away from that y letter, so it goes down and to the left in blue. And then to get to 6 in the z, you go up 6 units. So see how they kind of line up. The 6 in the z lines up with the, let me actually put this point in here. So this point is right there, point P. Okay, now the first couple are pretty simple. It says, how far away is this point from the xy plane? Well, from the xy plane, that is just the z component. So it's just 6 units high. So the answer is 6. the YZ plane. The YZ plane would just be the X distance, so it's the green amount, so it's 2. And the XZ plane, which would be basically you're looking at the Y coordinate, the missing coordinate, so that's the distance blue, which is negative, well, it's -4, but we don't care about negatives for distance, so we just call it 4. Okay, now it asks, what's the distance from that point to the x-axis? Well, from this point down to the x-axis, we're going to consider its Pythagorean theorem using the y and z components. So this distance would be the square root of the y component squared plus the z component squared. Well, that's equal to the square root of 16 plus 36, which is the square root of 52, which turns out to be 2 square root 13. So it's the same as 4 times 13, and the 4 comes out as a root 2. I probably used the wrong colors for this, but it'll be okay. The y-axis, which I should have done in blue, the y-axis is going to be the Pythagorean theorem of using the x value squared and the z value squared. I mean, you could draw these triangles in, but it gets messy real fast. So this is 4 plus 36, square root of 40, which would be 4 times 10, and the 4 can come out as a 2, so it's 2 root 10. And then in violet, the z-axis, which would just include the x component squared and the y component squared, would be the square root of 4 plus 16, square root of 20, which is the same as 4 times 5, but the 4 can come out of the square root as a 2, so it's 2 root 5. So that's how you get those. Problem 13. Okay, problem 14 is going to be a sphere in standard form. Well, we've seen this, but I'll write it. A sphere in standard form is x minus h squared plus y minus k squared plus z minus l squared equals the radius squared, where the center of this sphere is located at the point h, k, l. Okay, so our problem is, and I'm going to rewrite this as I go, it's x squared plus 10x. So I'm going to pair x's together and y's together. So then we're going to have plus y squared minus 4y. Then we're going to have plus z squared plus 6z equals negative 29. So what I did with this equation was I paired all the x's together, the y's together, the z's together, and then I put any numbers on the other side of the equal sign. Now we're going to do something called complete the square. Now students tend to think this is harder than it is. It's not too bad. X squared plus 10x I can write as x plus 5 squared. Now if I were to FOIL that out, I would get x times x, x squared, plus 5x plus 5x plus 10x, but I would also get plus 25. So over here, we have to add 25. So foiling this out, and I encourage you to practice this, but this is Calc 3, so I'm not going to show you everything. Foil that out, you'll get an extra plus 25, which means I have added 25 to the left-hand side. To balance that, I must add 25 to the right-hand side. And that's really the hardest part about this problem, is getting that. Then I'm going to do the same thing here, minus 2 squared. Now how am I getting these numbers? Notice 5 is half of 10. Negative 2 is half of negative 4. And I'm going to add over here negative 2 squared, which is 4. Plus, this is going to be z plus 3. Half of 6 is 3. If you FOIL that out, you'll get z squared plus 6z plus 9. So I have to add this 9 over here. And so we're going to get x plus 5 squared, y minus 2 squared, z plus 3 squared equals, let's see here, this is minus 29 plus 29, so those are going to cancel, plus 9, which we're going to call 3 squared. So that means our center is at, oh, they want me to write the whole thing out. Let me pause it so I don't waste your time. Okay, so I've kind of filled this in so you can see it. In standard form, you're going to write the x plus 5 squared, the y minus 2 squared, and the z plus 3 squared equals 9, the radius squared. Now the center, be careful. The basic form of the sphere is there's a minus sign in each bubble. So if the bubble has a plus sign, that means that the number had to have been a negative. So this plus 5 means the center is actually at negative 5, because the standard form wanted that minus sign there. Therefore, the center is at minus 5. Since this is a minus 2, that's the same form as the general form of the sphere, so k is just 2. And then this positive 3 means that L had to have been a negative 3 to flip that negative to a positive. And then the radius was 3 as we've written here. So that should get us for 14. Okay, 15 is going to be very similar. There is an added step though. So notice that each of these x squared, y squareds, and z squareds have the number 2 in front of them. So we're going to immediately divide everything by 2, and we're going to get x squared plus y squared plus z squared equals 4x. Don't forget everything divided by 2. 8z plus 1/2. Now that's going to be the only unfun thing, is we're going to have to deal with fractions now. Okay, now let's combine x's with x's, so we get minus 4x. Y squared, there is no other y term, so y squared is all by itself. Z squared plus 8z equals 1/2. And now we're going to do the same thing. So we're going to complete the square, x minus 2 squared, which means we're going to have to add 4 to the side. And we're actually going to write this as y minus 0 squared and add 0. And then we're going to write this as z plus 4 squared and add 16 because 4 squared is 16. So we're going to get x minus 2 squared, y minus 0 squared equals 20. They're going to want this, I know what they're going to want. They're going to want this as one number. So it's 20 plus 1/2, which is really 40 over 2 plus 1/2, which is 41/2. I bet that's how they're going to want it. Okay, so the center is at 2, 0, and -4, and the radius is the square root of 41/2. And I hope they don't want you to rationalize that, but let's see what they want. Let me type it in and try it. Okay, so they're nice to us. They didn't care about rationalizing that fraction. I mean, I guess the whole thing's under a square root, so there's really nothing to rationalize. But what we have here is what I wrote, just typed out, and then the center, again, would be it's just the number if there's a minus sign, and it's the opposite of the number if there's a plus sign. So 2, 0, minus 4. And then our radius is the square root of 41 over 2. Oh, joy, last problem. Okay, let's give it a look. Okay, for the last problem, kind of a doozy, honestly, we have to find an equation of the set of all points equidistant from the points A, -2, 4, 4, and B, 5, 3, -1. Now, between any 2 points, there has to be a plane in between those two that that plane, any point on it, is equidistant to both of these points. So the way you find it is, we're going to use distance formula, and we're going to say x minus -2, I'm not going to show all these steps because there's a lot, plus y minus 4 squared, z minus 4 squared. This is the distance A to any point P, a point on the plane. Well, that has to be equal to the square root of a BP, so it would be x minus 5 squared plus y minus 3 squared plus z plus 1 squared, which is the distance from point B to any point on the plane. Okay, so notice how we set this up. It's just distance formula we've done many times already in this section. And in the left-hand side, the x, y, and z numbers are just the numbers from point A. Remembering that the distance formula has minuses in it, so if I have a minus 2 for x, it becomes plus 2 because the minus is flipped. Otherwise, it's minus 4 and minus 4. And on the right-hand side, those numbers come from point B. Again, negative numbers will flip. So 5, 3, and minus 1 becomes plus 1. Okay, now we can square both sides and just get this, x plus 2 squared, y minus 4 squared. That has to equal x plus 5 squared, y minus 3 squared, z plus 1 squared. Okay, now you're going to love this. You have to FOIL these 6 terms. So this is going to be great practice in foiling, and I'm going to do it really fast. You're going to get x squared plus 4x plus 4 plus y squared minus 8y plus 16 plus z squared minus 8z plus 16. That's the left-hand side. Let me use a little color to help us here. The right-hand side, if I FOIL all this stuff, and I'm going to write it below this other one, you'll see why. This equals x squared plus 10x plus 25 plus y squared minus 6y plus 9 plus z squared plus 2z plus 1. Now, because these are on opposite ends of the equal sign, this is really a big subtraction problem. So the blue's on the left, the purple's on the right. I want to move everything to one side, and that means I'm going to subtract. So to do this really easily, I'm just going to say, okay, I've got everything lined up. All we have to do is draw a line and subtract going down. So x squared will cancel. 4 minus 10 is minus 6x. 4 minus 25 is minus 21. Y squareds will cancel. The nice thing about this problem is all the second order terms, the x squared, y squared, z squared will cancel. Be careful on this one. Minus 8 minus minus 6 will become positive. Minus 8 plus 6 is minus 2y. 16 minus 9 is plus 7. Z squareds cancel. Minus 8 minus 2 is minus 10z. Ooh, let me make sure I've got the letters. Yep. 16 minus 1 is plus 15. Now, on the right side is 0. Okay, so now let's see if we can simplify that. We're going to end up with, on the left, minus 6x. Let me just write the letters. Minus 2y and minus 10z. All the numbers are going to go to the right side, and they're going to flip. So this is going to be 21 minus 7. Zeros don't matter. Minus 15. And so we're going to get on the right side, minus 7 and minus 15 is minus 22, so you get minus 1, nice even number. And over here you're going to get minus 6x minus 2y minus 10z equals minus 1. And I'm sure they don't want all these negatives, so probably the easiest thing to do is flip everything. 6x plus 2y plus 10z equals 1. There's a common 2 to every term also we could divide out, but since since that introduced fractions, let's see if we can get away with not doing that. So we're going to have 6x plus 2y plus 10z has to equal 1. And let's see if that gets it. Okay, it didn't like that, so let me check my algebra quick. Okay, those of you who watch me have the luxury of being frustrated as you watch me carry an error out. So I caught it, but too late. For some reason I wrote that as a plus. So let's see how that's going to percolate down and screw this up. So, boy, let's just use the red pen and try to just correct this as we go. So that should have been minus, which would have changed this to the purple x squared minus 10x plus 25 is going to stay the same. I believe that's the only error that's going to cause an issue. So you get 4 minus minus 10, which becomes plus 14x. Should be the only error. So we would have, this would have been 14x. I believe everything else should have stayed the same. And now there might also be a second thing. They might want us to solve for one letter. Usually the equation of a plane is x equals some combination of y and z and a number. But if you have it in general form, you should be able to have all 3 letters on one side. Let's try it. So we're going to have 14x, if I didn't make another mistake, plus 2y plus 10z has to equal 1. And cross your fingers. Okay, unfortunately it counted it wrong, and I don't see why. So this is the approach. I didn't see any arithmetic errors anywhere, but this would be the approach. And it is okay to have all your letters on one side and your number on the right side. Yeah, I don't see the error. So do this approach. Put in the distance formula for both points, square both sides, FOIL, combine all the like terms, and you should get some x, some y, some z equals some number. And if you type that in there, it should be correct. And then the plane will be perpendicular to AB. So that will complete section 12.1.